Hi, welcome back. This is Professor Rich, and today's lesson is on section 6.2, System of Equations in Three Variables. So basically for three variables, we're going to do it by elimination, and it's just an extension of what we did in 6.1 for two variables. Okay, so pick any variable, doesn't matter, x, y, or z, and you want to eliminate that from two equations. So take two equations and eliminate a variable. So let's eliminate y. Eliminate y using equation about 2 and 3. So we want to get rid of y. So again, you ask yourself, all right, how are we going to get rid of y? What's the LCM for y and negative 2y? And the answer would be it would be 2y. So we need to take equation 2, multiply it by 2, and we get 4x plus 2y plus 4z equals 6. Equation 3, we don't need to do anything to it, so leave it alone. Or if you rather prefer, multiply it by 1. Same thing. And we get 7x, the y's cancel, plus 5z equals 6, and we're going to call that resulting equation 4. Okay, so that's step 1. Now step 2, using the remaining equation, so meaning the one that we haven't used yet in step 1. So in this case we use 2 and 3, so we have to use equation 1. So use the remaining equation and one of the other two and eliminate the same variable. So that's key there, the same variable. So we have to use the remaining equation, equation 1. So step 2, use equation 1 and one of the other variables. So we'll use, and we got to eliminate y. Okay, we have to eliminate y because we want to get two equations with the same two variables when we're done with this step. Alright, so equation 1, and we're going to get rid of y, so let's use equation 2. The LCM for 6y and y would be 6. So I need to take equation 2 times 6, get 12x plus 6y plus 12z equals 18. Equation 1, we're going to leave it alone. X, well actually we need to make them opposite, so we're going to take equation 1 and times it by negative 1. So we get negative x, negative 6y, negative 3z is negative 4. And then we get 11x plus 9z equals 14. And we'll call that equation 5. Now I could have used, did an equation, now looking at the problem again, I could have used equation 1 and 3, that would have been just as easy. But it doesn't matter. The only requirement is we have to use equation 1 and one of the other two. So I could have used equation 2 or 3. Step 3, we're going to take equations 4 or 5, or of course multiples of 4 or 5, and eliminate another variable. And we're going to call the result equation 6. Okay, so we're going to take 4 and 5. Let's eliminate z. No, that won't be, yeah, I guess it doesn't matter. Eliminate z. So what's the LCD for 9z and 5z? It'd be 45. So we need to do the first one by 9. So 63x 45z equals 54. And then we need one negative, so we'll do negative 5. So that's negative 55x. Negative 45z equals negative 70. So we end up with 8x equals negative 16. We call that equation 6. All right. Now, from here, we're going to solve equation 6. So step 4, solve equation 6. So here's step 4. We can take 8x divided by 8. Take 16 divided by 8. The golden rule, what you do one side, do the other. To the other. So you're going to divide both sides by 8, and you get x equals negative 2. Step 5, now we're going to, once we solved for one variable, and the idea, remember, this is going to be a point, well, I guess I haven't talked about it, but we're in 3 dimensions, which is 3 space, and each line represents each equation represents a plane, and these 3 planes can intersect in a single point. So we're looking for an XYZ, an ordered triple. All right, so what we're going to do now, step 5, is we're going to plug that result from step 4 into equations 4 or 5, either one. So let's take equation, they're about the same. Let's take equation 4, a little bit smaller. And I'm going to plug the x, the negative 2, in for the x. Okay, so 7 times negative 2 plus 5z equals 6, and then I'm going to solve for that for another variable. So in this case, I'm solving for z. So add 14 to both sides, so 5z is 20, and divide by 5, so z equals 4. Okay, and then step 6. Okay, so step 6, take results from step 4 and 5, so the 2 variables you just found, plug them into either any one of the equations, 1, 2, or 3, and then you're going to find the remaining variable. So let's take equation 2, 2x, put in negative 2 for x, plus y, plus 2z, z is 4, equals 3, and now we've got to solve it for the remaining variable, which in this case is y. So 2 times 4 is 8. Simplify. Negative 4 plus 8 is positive 4. Subtract 4 from both sides. Y equals negative 1. And then again, it's not really a step, but I like to emphasize it. Our solutions are is a point in 3 space. So write your answer as a point. Unless it's one of the special cases, which we'll talk about in a minute. So our solution is the x is negative 2, y is negative 1, z is 4, so it's the ordered triple, negative 2, negative 1, 4. Okay. All right, let's look at this example. Now, notice, equation 3 has z already missing. So if you already have one equation with the variable that's missing, basically it's just, you can skip the first step. Instead of taking 2 equations, eliminate a variable. Equation 3 has z missing already, so that's going to be my equation 4. Since z is missing or eliminated already, right? So now step 2, I have to use the equations I haven't used yet, 1 and 2, and I have to eliminate z. So remember, you got to use all 3 equations. So basically the first 2 steps is you want to boil this equation down into a system of 2 equations, 2 variables. So I'm going to eliminate z using equation 1 and 2. Okay, and the conditions, you got to use all three equations. And you got to eliminate the same variable. So if I use equation 3, z is missing. So I don't need to use another equation. But step 2, I got to use equation 1 and 2 and get rid of z. And luckily, I don't have to do anything to them. I can just straight add them. So this is saving us a lot of work. So relatively easy so far. So we get 5x minus y, the z's cancel, equals 12. And that's equation 5. So equation 4, remember, is the same as equation 3. And equation 5, they're actually the same equation. So if I were to do step 3 and eliminate a variable, say y. So I'm going to take equation 4 times the negative. You get negative 5x, positive y, negative 12. Equation 5, 5x minus y equals 12. You get 0 equals 0. No more variables. Well, this statement's always true. So that implies that we're going to have an infinite number of solutions. Now again, we're in 3 space now, not 2 space. We're not on a plane, we're in 3 space. Length, width, and depth. So like our physical environment's 3 dimensions. If we count time, that would be a 4th dimension. So there's going to be an infinite number of solutions. And with when you're in 3 space, there's 2 possibilities. You can have a line as your solution or a plane. Okay, and again, one equation represents a plane. So if all 3 of these planes were the same plane, we wouldn't be able to do either step 1 or 2 to get another equation. They would all be multiples of each other, and then your solution would be that plane. You just write one of the equations down. In this case, we have a line because we're able to do step 1 and 2. And we get this equation, 5x minus y equals 12. And from here, okay, this is confusing the first few times that you do it. But the idea is you're going to pick one of your variables. We're going to write this line as a point. And so the idea is you're going to pick a variable, pick one variable, it doesn't matter which, to be what I call a free variable. And write the other 2 equations, or solve the other 2 variables in terms of your free variable. Okay, so what do I mean by that? So if I look at equation 4 or 5, doesn't matter which, I see I have x minus y equals 12. So if you don't understand too much, just say, okay, you take this equation, solve it for one variable. It doesn't matter which. Pick a variable. So let's pick y. So if I subtract 5x and then divide by negative 1, I get y equals 5x minus 12. Now notice y is written in terms of x. Y is whatever x is times 5 minus 12. So if I choose x to be my free variable, see, now I have y written in terms of x. So free meaning there's no restriction on it, right? It's free from restrictions. It can be whatever I want it to be. And I'm going to write my answer as a point, even though it's a line. So x is free. It can be whatever it wants to be. So you get to choose x. X could be 1. But once I choose x to be 1, then y is going to be 5 times 1 minus 12, which would be negative 7. Now you got to figure out what z is in terms of x. So now you go back to equation 1. Now we need in terms of x. So we go back to equation 1. So now take equation 1, x plus 2y minus z equals 4, and plug in the y, which is, substitute 5x minus 12 for y into equation 1, 2, or 3. So we're going to get x, I'm going to put it in equation 1. We get 5x minus 12 and solve for z in terms of x. Okay, so you're going to do x plus 10x minus 24, just simplifying. Distribute. Combine like terms, 11x minus 24 plus, minus z. And I'm going to add 24 to the other side. I'm going to subtract 11x to the other side. So I got negative z equals 28 minus 11x. And then I'm going to divide by negative 1. So z equals, let's write it so the x is first. So it'll be positive 11x minus 28. Okay, so now you can see your points are x. It's the free one. It could be whatever I want it to be. And then y is whatever x is times 5 minus 12. And z is whatever x is times 11 minus 28. And then remember, in geometry we said that a line, 2 points determines the line. So what you could do is, so 2 points on this line are so you pick a number like 1 for x, and then 5 times 1 minus 12 is negative 7. 1, and then for z, 1 times 11 is 11, minus 28 is negative 17. So you could plot that point in 3 space, and then let's find another point. Let's do something easy, like 0. If x is 0, y would be 5 times 0 minus 12, which is minus 12. And z would be 11 times 0 minus 28, so it's minus 28. You plot these 2 points and then you could draw the line through it. Okay, now that's pretty hard to do when you're in 3 space, because if you're to graph 3 dimensions, right, this would be x. The vertical axis is now your z-axis, and then coming out at you is your y-axis. And so if you wanted to plot 1, negative 7, and coming at you, that's the y, that's the positive going, right, that would be positive 1. So 1, negative 7, 1, negative 7, and then you would go down 17. So that would be the point 1, negative 7, negative 17. But again, it's hard to visualize once you put it on a paper like that. You know, you can't tell really where that point is. So anyway, that's the way you would do it if you wanted to do it. All right, let's look at another one. So my step 1 is I'm going to take equation 1 and 2 and eliminate, well, let's do 1 and 3 and eliminate x. So equation 1, equation 3, we just need to change the sign of one of them. So negative x, negative 3y, negative 4z equals negative 1. 3 we leave alone. Now it's really important to get in the habit of doing this notation. The book, I don't think the book shows it this way. Most teachers don't. It's kind of what I've done through the years, and it really helps students out for a couple of reasons. One is sometimes you get lost in what you're doing, and then you can look at this notation here. Oh yeah, I took -1 times equation 1, and I'm going to add it to equation 3. And then you can go back later, you know, if you made a mistake, you can go back and see, okay, did I forget to do something? And you can look at the notation so you know where you got these numbers. So let's see, the x's go away. 5y plus 7z equals 1. That's equation 4. Now, I have to use equation 2, and I have to get rid of x. So using equation 2, and how about equation 1? And the LCM for x and 3x would be 3x. So equation 2 we're going to leave alone. Equation 1 we're going to times by -3. So we get -3x, -9y, -12z equals -3. And we get, the x's cancel, -5y, -7z equals 0. Now step 3, we're going to take equation 4 and 5 and get rid of another variable. So let's get rid of y, but notice it looks like we're going to get rid of both of them. So is this going to be an infinite number of solutions? And the answer is no, because again, if the variables go away, you look at the statement that's left. That statement, is it true or false? If it's true, then it's an infinite number of solutions. And then you do the procedure that we did in the last problem. But this one's false. It's always false. So that tells you no solution. That's nice about this one type. No solution. You don't have to go any further. Right? We don't need to worry about it. Now again, in 3-space, there's more going on. So it's not necessarily parallel planes. In fact, it's pretty rarely that. You can have each plane individually intersect one of the other ones and still have no solution. So, you know, there's more stuff going on. It's too hard for me to draw it for here. If you look in the textbook, they show some good pictures, or on my math lab. Okay, so, you know, if you get a statement with no variables in it, if it's true, then it has an infinite number of solutions, and then you got to continue with the process. If it's false, like this one, then you just stop, say no solution. Okay, you get a contradiction, you're done. Okay, so we can extend this process to in many equations with as many variables as we want. So the idea to get a single point as a solution, though, you need the same number of equations as the number of variables. So in this case, we got 4 equations with 4 variables. And the idea now is we're going to take this and boil it down to 3 equations, 3 variables. I don't know where I wrote that all out. Okay, so basically you're going to take equations 1, 2, 3, 4, and boil it down to equation 5, 6, and 7. And then you're going to boil that down to 2 equations, 2 variables. I'll just write 2 variables. So that's equation, now we're going to be at 8 and 9. And then down to 1 equation, 1 variable. That'll be equation 10. Okay, so that's the process. So let's start and see how we do. So we're going to take equation 1 and 2 and let's get rid of z. Eliminate z. So equation 1 and 2. And we're going to get w plus x minus y plus z equals 0. And we'll get negative. We've got to change the sign, so they'll cancel. So we get w minus 2x minus 2y minus z equals minus 5. And we get 2w minus x minus 3y equals negative 5. So that's our equation 5. And then we're going to take equation 1. So we did 1, 2. So that rule is you got to use all four equations to get 3 equations. So we used 1 and 2. We can do 3 and 4, or we can do 2 and 3. And then 1 and 4 or something like that. But we have to use all 4 equations. And you do it 2 at a time. So basically there's 3 of these, 3 combinations we got to do. Okay? So I'm going to take 2 and 3, which is negative w plus 2x plus 2y plus z equals 5. And equation 3, again we got to eliminate z. And this is going to give us equation 6. So 3 is negative w plus 3x plus y minus z equals negative 4. And that gets me negative 2w plus 5x plus 3y equals 1. And we got to do it one more time. So again, the only restriction here is we eliminate the same variable, and we have to use all 4 equations, doing 2 at a time. Okay, so even I could do 1 and 2, 3 and 4, that takes care of using all 4 equations. But again, I would have to get a third equation because I need to get 3 equations with 3 variables. Okay, so you got to do this process 3 times with 2 at a time. So I've used 1 and 2, 2 and 3, so now I need to use equation 4. I have to use equation 4. And let's use equation 1 again. So 1 and 4. And we got 3z. So we got to multiply it by 3. So we got 3w plus 3x minus 3y plus 3z. 3 times 0 is 0. Equation 4 we leave alone. Plus x plus y plus 3z equals negative 7. We put that together and we get w plus 4x minus 2y equals negative 7. And that's equation 7. So now we have these 3 equations, equation 5, 6, and 7, and it's now from here, it's just like we've done before. Okay, so we got to get it down to 2 equations. So I take 5 and 6, and let's get rid of y. Okay, eliminate y. So 5 and 6, we get 2w minus x minus 3y, negative 5. 6, negative 2w plus 5x plus 3y equals 1. Oh, and we get a bonus here because we eliminate 2 variables. Yeah, but my focus was on getting rid of y. So I got rid of w2. That's a bonus. That's going to save me a step. Okay, and we'll call that equation 7. And now I've used 5 and 6. Now I'm sorry, that's equation 8. If you look at my chart up there. Which is also going to become my equation 10 too. See, that's going to save me a step. So I did 5 and 6. Now I got to use 7. And so let's do 6 and 7 and eliminate y. Alright, so that's my conditions. Use all 3 of the equations to get 2 equations with 2 variables. So let's see, 6 is, and 7, and I'm eliminating y. So I got 3y and 2y. So the LCM would be 6. So I got to times the top one by 2, or equation 6 by 2, and equation 7 by 3. So equation 6 by 2 is negative 4y plus 10x plus 6y equals 2. Equation 7, I'm multiplying everything by 3, so I get 3w plus 12 x minus 6y equals negative 21. And this is going to become my equation 9, which is going to be w plus 22x, minus w plus 22x equals negative 19. Now, I get to skip the next step from 2 equations to 1 because equation 8 is already done. 8 is going to become my 10, so I can skip this step. Right? 10 is 4x equals negative 4. Now, once you're there, once you're at one equation, one variable, then you're going to solve that equation for the one variable. Okay. So now I'm going to solve equation 10 for the one variable. Divide by 4. Divide by 4, so x equals negative 1. And then from there, you're going to take the one variable, plug it into a 2, plug into equation 8 or 9, and solve for a second variable. Okay? So on the next page I will do that. But let me go ahead and just write. And then you're going to take the 2 variables, plug in the 2 variables into equation 5, 6, or 7 and solve for third. And then you take it and come back up to here, plug in the 3 variables into 1, 2, 3, or 4 and solve for the last one. I'll just write 4th variable. Okay? And then you can extend that. You just add another layer on top. So we can go 5 equations, 5 variables, and now you're going to do 4, taking 2 at a time to get 4 equations, 4 variables. So you can see the work just starts expanding and expanding, but you could do it. You can extend it to as many as you want. Okay, let me finish this on the next page. So I got x equals negative 1 from solving equation 10, which was actually equation 8. Now I'm going to plug that into equation 9. That's one with 2 variables. 2x equals negative 19. And put in the negative 1, which is negative 22. Add 22 to both sides. So negative w equals 3. So divide both sides by negative 1. You get negative 3. So now we got 2 variables. So now we're going to go up the chain there. So we're going to go to 3 equations, 3 variables. So 5, 6, or 7. And we're going to plug in, let's use 6. So equation 6. So we're going to take the 2, the negative 2w plus 5x plus 3y equals 1. We're going to plug in the w, which is negative 3. Plug in the x, which is negative 1. And now we're going to solve it for another variable, for y. So we get 6 minus 5 plus 3y equals 1, which is 1 plus 3y equals 1. Subtract 1, so 3y equals 0, y equals 0. And so now we're going to take those 3 results and plug it into equations 1, 2, 3, or 4. Let's use 1, which is w plus x minus y plus z equals 0. W is negative 3, x is negative 1, y is 0, and we've got to solve for z. So we get negative 4 plus z equals 0. Add 4 to both sides. So z equals 4. And now, the final step, these are quadruples, right? Ordered quadruples. So w is negative 3, x is negative 1, y is 0, z is 4. Okay, so now we're in 4 space instead of 3 space. 4 dimensions. Alright, so that concludes the lesson for 6.2. Go to My Math Lab, complete your exercise there, and I'll see you next time.